Hey, good morning, guys. It is Thursday. Get you here. How can so this is investigation 3.3 using prime factorizations. How can the prime factorization of a number be used to find LCM and GCF of two or more numbers? We're going to look at two different ways on how to find GCF and two different ways on how to find LCM. It says look at your math book, page 48 and 49. You do not have that, so I will show you everything you need to do. So first off, the two numbers we're talking about are 24 and the number 60. Okay? So Sasha's strategy is going to be list all the factors of 24 and 60. So in this case, you need to know all the factor pairs of 24 and 60. So we're going to label that first off right here. So I'm going to pause the video, list all the factors of 24 and 60. I'll give you one. So let's say there's 24 and 60. Okay? Just put a colon there, so we're going to have 1, 24, 2, and 12, 3, and 8, 6, and 4. So go ahead and list all the factors for 60. Okay, so step 1 would be to list all the factors like we did, so you can see now I have 60. And step 2 is just identify the greatest shared factor. So as I'm looking along, the greatest factor that I see they share is going to be a 12. Okay? So it's a 12. Now, Derek's strategy is a little bit different. It has to do with finding the prime factorization of each number. So we're going to find the prime factorization of 24 and of 60, right? So this is like this. Remember we did this? 2 and 12. I'm going to say 3 and 4, 2 and 2. Okay, and now for 60, I'm going to do the same thing, do the prime factorization, pause the video to do that, and then start back up to see the answer. Okay, so I have all the prime factors. I'm going to circle the ones, we always circle like this, right? These are all prime factors. Here's the prime factors for 60. And then what I'm going to do is I'm going to find the ones that are shared, and they're going to go in the middle. So they share a 2 and a 2, so those are gone in the middle. They share a 3 and a 3, so that's going to go in the middle, and they share a 2 and a 2, and that's going to go in the middle. What's left over for 24? Just this 2, so this goes right there. What's left over for 60? Just that 5. Okay, and so what you do in the middle here is you're going to do 2 times 3 is 6, times 2 is 12. The GCF is 12. Okay, and you can see the same answers there. So that is how you do the GCF. List the factors this way, the prime factorization. I like the prime factorization way, and it leads into our next conversation. Alright? Okay, so Sasha's strategy, I know you can't see it, but her strategy, it's to list all the multiples of 24 and 60, because now we're talking about the lowest common or the least common. That means that the lowest number that they both share. That's a multiple. Remember, factors are equal to the number or smaller. Multiples are equal to or bigger. So it's going to be 24, 48, 72, 96, 120. And I'm hoping that you see 120 right here. So the first one over here is going to be 60, and then 120. This is a little bit more work because you have to know all your multiples. If you have a calculator, you're good to go because you just be 60 times 1, 60 times 2, 60 times 3. That's what I was doing here. 24 times 3, 24 times 4, 24 times 5. And we can see that they share, we identify the lowest common number, multiple, that they share, be 120. For LCM, it's going to be the same thing that we did up here. We're going to get the prime factorization of 24 and 60. Right, so I'm going to rewrite this whole thing down here just so you see it. And so pause the video, do that, and then start it up again. Okay, so I went ahead and wrote basically the same prime factorizations I did up above. Okay, so once you do this once, you're good to go. And I'm going to identify what they share goes in the middle. So they share a 2 and a 2. They share a 3 and a 3. They share a 2 and a 2. Okay, they don't share this 2 right here, and they don't share this 5. So I'm sorry, I should have put this earlier. 24 is here and 60 is here. Now, LCM is pretty easy. all you have to do is you multiply all of these numbers in these boxes together. So the leftover 2, so it's 2 times 2 is 4, 4 times 3 is 12, 12 times 2 is 24, and I know you don't know this, but 24 times 5, 1, 2, 3, 4, 5, equals 120. So to me, this way is a little bit easier. It takes a little more work up front, but it's like a 2-for-1 special. Did they get the same answer? They sure did. 120. Alright, so there you go. We're going to do some more on the next page. So go ahead and pause the video. Okay, so now we're on the back side. It says use the prime factorization of 72 and 120 to find their GCF. That's going to be the number in the middle they share. So I'm going to go through and do the prime factorization of 72. You could use any two numbers that you chose. I'm just using this, 18, 2 and 9, and we get 3 and 3. Let's circle those are all primes. Then we have 120, I'm going to use 10 and 12. This is 2 and 5. This is 3 and 4, and we get 2 and 2. Circle all the primes. The numbers they share go in the middle, so they share a 2 and a 2. They share another 2 and another 2. They share another 2 and another 2. And they share a 3 and a 3. The 72 they don't share as a 3 here, so that's going to come over here. And they don't share this 5. And so again, the GCF is 2 times 2 is 4. 4 times 2 is 8. And 8 times 3 is 24. That is your GCF. Okay, the LCM is going to be 3 times 24 times 5. I don't even know that off the top of my head, so let me get my calculator out here. Alright, so I multiplied 3 times the GCF, which was 24 times 5, and I get the answer of 360. So 360 goes in there. Alright, so there's another vocabulary word that you could be introduced to. It's called relatively prime, which means that they don't have a lot of factors. So 25 and 12 are considered relatively prime. So when you look at 25 and 12, they're relatively prime because they only share a factor of 1. So the greatest factor that 25 and 12 shares is the number 1. So find another pair of numbers where the GCF is 1. So what's another set of numbers where the greatest common factor is 1, and those numbers can't be prime? So that has to be like composite numbers like 25 and 12, but cannot be prime. So go ahead and pause that. Think about what two numbers go together that have a factor or a GCF of 1 that are not prime. If you're a little bit stuck, two numbers that go together would be 39 and 20. Their GCF is 1. So usually it's going to be an odd number and an even number, and they're not going to share any bigger factors than 1. How can you determine whether a GCF of two numbers is 1? By looking at their prime factorization, right? So you basically look at the prime factorization of the numbers, and if they don't have any factors, like these have factors they share. If they don't have any of these factors that are shared, then the GCF is 1. So as you look at the prime factorization, if they don't share any of these numbers, then that'd be it. So like right here I did 39, which is 3 and 13, and 20 is 2 and 10. So I start circling the prime numbers. So if you get to this point, you're like, wait a minute, they don't share anything, then 1 is the GCF, okay? Alright, so then every once in a while, you're going to see this come out. So find two pairs of numbers whose LCM, the least common multiple, is a product of those two numbers. So the product, so those two factors multiplied together, those two numbers will make their LCM as well. So two numbers, like say 3 and 13, when I multiply them together, I get 39. Okay, both those are prime. So how about 6 and 7? Well, they're not their GCF, their LCM is 42. So the secret is when you start seeing prime numbers, sometimes you can just multiply them together and find out that their product of those two numbers are going to be the LCM as well. Now, if I think about two numbers who have an LCM less than the product of numbers, like let's say 12 and 15. Okay, if I multiply them together, I get 180, right? That is not the LCM. The LCM for 12 and 16 is 60. So it's important that you just don't always multiply the numbers together. It does give you a multiple, but sometimes it's not going to give you the lowest. So this is actually, if you look, 120 is lower than 180. So even that way, it's too big. So moving on, how can you determine whether the LCM is the product of the numbers or is less than the product of numbers? Well, typically it has to do with prime numbers. So when you see prime numbers, the product is usually going to be multiplied the two numbers together. When you have two composite numbers that are bigger, like 12 and 15, there's probably going to be an LCM that is lower than the product of those two numbers. Okay, and the last thing it says, so go ahead and write your answers in there. The prime factorization of a number is 2 times 5 times 3 times 2. Find the two numbers whose LCM is this number. Right. So I'm going to multiply this. 3 times 3 is 9, times 5 is 45, times 2 is 90. So this is equal to 90. So what they're saying is find two numbers whose LCM is 90. And then they want you to find two numbers whose GCF is also 90. So the LCM, these are going to be numbers that share, right? These are multiples, like, like say 30. So it's going to be like 30, 60, 90, right? So you have to list out the multiples. This is the multiples here, right? And these factors are going to be numbers that are being multiplied into them, right? So these are GCF, that's LCM. Go ahead and try that. If you get stuck on it, we're going to talk about it during math today. So that's the lesson. Talk to you guys soon. Hope it makes sense. If you get stuck on these, we'll talk about answers when we come back.